Dear students, after studying this module, you shall be able to understand what are annulenes, how do you synthesize annulenes, what are the reactions possible for annulenes. Annulenes. These are completely conjugated monocyclic hydrocarbons. They have general formula CnHn. According to the IUPAC naming conventions, annulenes are named as N-annulene, where N is the number in the bracket indicating the ring size or the number of carbon atoms in the ring. For example, cyclobutadiene, it is named as 4-annulene as the complete ring consists of 4 carbon atoms. Benzene is named as 6-annulene. We know benzene has 6 carbon atoms. Cyclooctatetraene is named as 8-annulene as it is a 8-membered carbon ring structure. Cyclododecahexane is named as 12-annulene. Cyclotetradecaheptane is named as 14-annulene, whereas cyclohexadecaheptane would be named as 16-annulene, all based upon the number of carbon atoms in the given ring structure. As it can also be seen, could be aromatic, could not be aromatic. However, the aromaticity would be based upon the various rules which follow the aromatic character. Annulenes were first prepared by Sondheimer et al. In 1962 to test the Huckel's rule for aromaticity. According to the Huckel's rule for aromaticity, if the number of pi electrons is equal to 4n plus 2, where n is equal to 0 or a whole number, the system is aromatic. This rule was also called as the Huckel's rule. The number of pi electrons for the Huckel's rule are 2, where n is equal to 0 if it is being substituted in the 4n plus 2 formula. 6 when n is equal to 1, 10 when n is equal to 2, and 14 and 18 when n is equal to 3 and 4 respectively. Various annulenes prepared were having n is equal to 10, 12, 14, 16, 18, 20 and so on. Out of these, only 14, 18, 30 annulenes have 4n plus 2 pi electrons and are found to be aromatic in nature. The 4-annulene, which is cyclobutadiene, has 4 pi electrons and is anti-aromatic in nature. It is highly unstable due to a high ring strain. It can be isolated only under the controlled conditions like in argon matrix or using trapping agents like dienes. Studies show that it has a rectangular structure rather than a square with carbon-carbon bond length of 1.567 angstrom and a carbon-carbon double bond length of 1.346 angstrom. The 8-annulene is also known as cyclooctatetraene. It is a polyunsaturated hydrocarbon which is a colorless to light yellow flammable liquid at room temperature. It is non-planar and adopts a tub conformation as shown to attain a stability in the given structure. The 10 and 14 annulenes are not particularly stable due to geometric factors. 10-annulene is also known as cyclodecapentaene since it has conjugated 10 pi electrons, but still it is not aromatic due to the combination of steric and the angular strains. Many conformations are possible for 10-annulene. Planar, all cis isomer. In this conformation, all the bond angles are 144 degrees, which creates a large amount of bond strain relative to the ideal bond angle of 120 degrees for sp2 hybridization. Boat-like all cis conformation. In this conformation, angular strain is less in comparison to 1, but still it is highly unstable. Planar, trans, cis, trans, cis, cis isomer. This conformation also suffers from the steric repulsions between the two internal atoms. Non-planar, trans, cis, 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 cis isomer. This is the most stable of all the possible isomers, as it is able to accommodate a lot of angular and the internal steric strains. The 14-annulene has 14 electrons in its conjugated pi system. Hence, it possesses some aromatic character. The 16-annulene is non-planar with alternating carbon-carbon double bond and a carbon-carbon single bond, like in the non-aromatic polyene system. The 18-annulene is almost planar with some aromatic stability. However, it reacts more like a polyene than a benzene. It undergoes addition reactions with hydrogen and bromine and deals at a reaction with maleic anhydride like any polyene system. The higher annulenes, where N is greater than 18, are of less synthetic interest. This is mostly due to their significant bond alternation symmetry and conformational flexibility. All the higher annulenes up to N is equal to 30 have been synthesized except for N is equal to 26 and 28. Synthesis of annulenes. 4-annulene. Cyclobutadiene, which is also called as 4-annulene, was first synthesized in 1965 by Roland Petit et al., although they could not isolate it. In 1965, the first stable pale yellow crystalline solid of cyclobutadiene iron tricarbonyl was prepared from iron carbonyl and cis dichlorocyclobutene via a double dehydrohalogenation reaction. As shown here in the figure, a complex was finally obtained. Cyclobutadiene iron tricarbonyl complex is known to decompose oxidatively as shown by the presence of ceric ammonium nitrate in the presence of ethanol. The liberated cyclobutadiene can be trapped with several unsaturated compounds as shown here, leading to the intermediate cyclobutadiene, which was trapped in the form of a diester. Liberated cyclobutadiene can be trapped with several unsaturated compounds in the presence of ceric ammonium nitrate and ethanol, as shown here in the number of reactions, leading to the formation of dimethyl phthalate or other addition products. If no trapping agent is used, cyclobutadiene dimerizes at 35 degree Kelvin as shown below. Synthesis of 8-annulene. Richard Willstatter synthesis of 8-annulene. 8-annulene or 1357 cyclooctatetraene was first synthesized by Richard Willstatter at Munich in 1905 by the root. Reppe synthesis of 8-annulene. Acetylene or ethylene on reaction with a warm mixture of nickel cyanide and calcium carbide under high pressure results in the formation of 8-annulene or cyclooctatetraene in the yield of 90%. 10-annulenes. Naphthalene on Birch reduction form tetrahydronaphthalene or isotetraline. Tetrahydronaphthalene, when treated with chloroform, potassium salt of tertiary butanol using ether and ethanol as solvent at minus 30 degrees centigrade, undergoes dichlorocarbene addition and forms 11,11 dichlorotricyclo 4,4,1,0 undeca-3,8-diene. This on further Birch reduction forms tricyclo 4,4,1,0 undeca-3,8-diene by removal of two chloride substituents. This on further oxidation with 2,3-dichloro-5,6-dicyano-1,4-benzoquinone, which is also called as DDQ, forms 1,6-methano-10-annulene. 18-annulene. The synthesis of 18 annulenes is achieved by the given reaction sequence. The reaction is carried out with copper acetate in the presence of pyridine at the temperature of 55 degrees, where the polymerization takes place between the different three molecules. This further undergoes a rearrangement in the presence of tertiary butoxide on heating and further reduction to form the 18 annulenes. Reactions of annulene. The cyclobutadiene reacts with ene to give Diels alder product. The reaction of ethylene and cyclobutadiene forms bicyclo 2,2,0-hex-2-ene. The reaction of cyclobutadiene and cyclopenta-1,3-diene, another Diels alder product, is shown. In another reaction, a cyclobutadiene reacts with allenes to form 5-methylene bicyclo 2,2,0-hex-2-ene. The cyclobutadiene iron tricarbonyl undergoes a number of different electrophilic substitution reactions similar to ferrocene or benzene, as shown by Petit and co-workers. Although these reactions are not particularly interesting in terms of mechanism or theory, they do highlight the aromatic character of cyclobutadiene iron tricarbonyl and serves as useful method for derivatizing the parent structure. The various reactions have been depicted here in the given scheme. Reactions of 6 annulenes. Benzene is 6 annulenes. This is a very well-known aromatic compound. This is highly unsaturated, but it does not undergo any regular reactions of alkenes such as addition or oxidation. It does not lead to the addition of bromine, no oxidation, no hydration and no hydrogenation, which might take place only under a high temperature and pressure. Benzene undergoes electrophilic substitution reactions, are typical properties of aromatic compounds. It reacts with bromine if a Lewis acid catalyst is present. However, the reaction is a substitution and not an addition like any alkene system. Some of the important reactions of benzene are like sulfonation, bromination, halogenation, nitration, hydrogenation, alkylation, acylation, all under the various conditions as shown here in the given scheme. Reactions of 10 annulenes. The 10 annulene existed in two distinct but rapidly interconverting forms 1 and 2, to which they assigned an all-cis boat-like conformation and mono-trans twist conformation. Both the isomers react thermally and give dihydronaphthalenes 3 and 4 as shown in the structure after the cyclization respectively. They also retain their respective cis or trans character. The lack of planarity and hence aromatic stability in both the conformations are responsible for the relatively high reactivity of 10 annulenes. The 10-annulene on hydrogenation gives cyclodecane. Reactions of 18 annulenes. 18 annulenes are another important higher annulenes. The low temperature NMR studies have suggested the three conformations of nearly equal energy for this molecule, with 3 internal protons above the plane and 3 below the 3 possible arrangements. For the reactivity, it acts like a localized pi bonds and gives addition rather than the substitution reactions. Its behavior is drastically different from benzene. 18 annulene has been shown to undergo thermal rearrangement reactions to give the 3 products which release benzene to give the stable product. To summarize, annulenes are conjugated monocyclic hydrocarbons with general formula CnHn. According to the IUPAC naming conventions, annulenes are named as N-annulene, where N is the number of bracket indicates the ring size or the number of carbon atoms in a ring. Some annulenes possess aromatic character while the others are non-aromatic polyenes. The higher annulenes, N greater than 18, are of less synthetic interest. This is mostly due to their insignificant bond alternation, asymmetry and conformational flexibility. The synthesis of selected annulenes are discussed like the synthesis of 4-annulene, 8-annulene, 10-annulenes and 18-annulenes. The 8 annulenes can easily be synthesized by Richard-Willstatter synthesis and Draper synthesis. The important reactions of 4 annulenes, 6 annulenes, 18 annulenes and 10 annulenes have been discussed here in this chapter.